You can do it. I'm leaving.
We're gonna make a position versus time graph and a velocity versus time graph. So we're gonna, let's see, the time is 10:24, so at 10, let's say 35, I know it says 15. So yeah, talk about where your axes are gonna be, what your axes are going to be.
No, time keeps going, so
Time is always.
position versus time. So position depends on what time.
Time is not dependent on the position.
This would be, so it doesn't look like.
For me, it's all about your. No. So we're doing the.
Alright, so. I'm following you.
The other one, we're gonna do this one versus this. We're not gonna change it.
A new position, right?
So which is one you want
Thank you.
Because this is your. This is gonna be position
I'm not saying it's wrong.
Well, I think it's right.
I think we did it.
And this is so, and velocity is gonna be in meters per second to time. Wait a minute. That's not position. I was going to.
No, I just moved over, just moved here.
We have it right.
So I guess here's my question though, we want to do time because we only have what, 6 so it's all gonna go to here.
You can, here, I'm gonna let you.
Okay. So we want to do half increments?
Just for how times the graph is. Yes, exactly.
Let's see. Madison, there you go.
I know a lot of people at MacArthur. Did you go, Mr. Bordelon?
No. I did go to MacArthur.
Oh, no, time.
But I actually taught at SCUC, so. And then Dr. Osa told me that, I remember she said you taught it at Madison. Yeah, are you the one who told her she should get her
And the velocity versus time.
No, but I knew that, and I never
Position
did
versus
tell her
time,
that.
that's gonna come straight from the table.
Okay, so we're going from
So
0
time is 1.
to 7?
Now, when we look at graph, if I'm doing 5 tenths increments on my x, do I have to do 5 tenths increments on my y? Do they have to be the same?
It just has permission.
What if you're
But it depends on the graph.
500,000 years and you're just
How you scale your graph affects the slope. It's so if you not make your y and x values exactly the same, very small, you might actually have a shallower.
And this is change over time, so we want to line up.
No, it's just because.
Ashley.
Somebody say
But I'm not
over.
showing that.
So it's okay to know.
Like we don't.
It's a combination position.
Yeah.
So it's just to accommodate that. Tim, you have to move your x and y axis up so that you can graph.
Do the American way.
Thank you.
Oh, I didn't even take it. Because it might go off the ground.
Position.
a certain amount of time.
Yeah, I should have moved it up. But my question is,
The crazy person at the sandwich board saying the end is near.
It's just my fault on the graph.
We're graphing the points, right? We're not changing up.
When I get to 7,
No,
I'm
you're
graphing the
Time is continuing. Well, let's go to, we know what, so we ask our kids to redo.
I don't know whether it's a screen or the screen.
so.
They had numbers on it.
I can even change.
3 seconds will be at 1.5.
But I was like, it could be like bunnies and
My actual question.
Yes, you are. You're saying you're always starting from baseline.
Yes, no, we're starting from right here. The x-axis.
You don't start from where you were at.
Because it's like, all these were here, which is all the patterns.
Okay.
I always plot X and all Yeah.
No, it's just your position over time.
Plot X, then
You're gonna
Y.
connect yourself.
Big one.
The velocity, if you don't.
Is this?
I gotta fix it, hold on.
Big one in there.
which one's the screen?
And I should have.
He's
He's not part of our, he's not part of our. Don't talk to him, he's not part of our group.
Meaning you don't connect the dots.
Don't let him get the luxury of being out of it.
I'm sorry, I finished mine. No problem.
Range is
This one you could.
Don't mean this one.
This one, it will be continued, right? So you have.
I did not connect to the in between. But when that's still be on our progression, like, is it still increasing through that time? If it happens that you're on half, it should still be at that point, right?
I just had to, wait, what did you, is that a message?
Right, I mean, that, I left mine blank because I'm gonna leave that
I
open
missed
right
that.
now. But when we get into that concept, I'm thinking that, well, if I'm continuing on that time, I should be getting that point if it's my turn. So, based on position of time, velocity.
You can make that work.
we could spread it out, make it
When I did mine, I did.
But for this one, we'll tell you.
Because my math partner isn't here to help me.
I'm not helping you, Kim.
That's all I'm telling you.
No, you are a wonderful stand-in math partner today. Thank you, Rochelle. You're amazing. No, I'm recording so I can go back.
I thought I said that.
Yeah, and then we have 5, 10, 0 here.
Okay, so what are we doing here? We have so you're gonna have to.
Oh, it's blocking.
So,
I understand.
Yeah, 5, 10, yeah. And then
We're gonna have trouble doing that.
Yeah.
Because this this, but the velocity
It's
is
always
already
constant.
B.
You know, if it's constant, then yeah.
And then at once,
But if it's not constant, then I can't find for a second, like I said, it could have been way up here. Right, yeah, 1 second, it could be right down.
So if I need to be able to have an idea, these do not make it.
So are we using average velocity?
But if it's at a traveling constant, then they.
So hey, Tanya.
Have to be up here.
So we're gonna, velocity is gonna start again. We're gonna take our tour out.
What I did was, too, I started right here.
Velocity is just
And 4.
Description of how.
So that's my 0.
Yes.
You don't want average velocity, we can all do.
Right, but I'm plotting against.
They can position it that way, they can divide it by the time.
So this would be good to use it.
But that would be the change in distance and not the position.
I did.
That would be like position,
Position.
Austin position, Waco position, Dallas.
Alright, so.
Do they mean on part 2 or an Oscar and a velocity?
Okay, I can do that.
Average
No, it doesn't wear.
It's not one each velocity.
So we are using this? Okay, just making sure.
Let me down small.
I wanted to buy one, yeah.
Okay, then how are we gonna do this? Here's point
That
A.
is,
It's gonna be, this time is 0.
2 seconds with
But
that one.
we don't have a time.
Why can't you just say time? You've got to do concrete, you've not given me class experience, don't worry about that. So until you experience a new vocabulary term, you need to take at least 4 to 6 hours. Yes, when those
Because we were looking at the change.
Yes, we're looking at the change, so you need to choose position here.
I need concrete experiences, I
To
need to
get
touch, I
at
need
the
to be in the
velocity where you need to choose.
At the time of
Because it's T2, I mean,
What did you want?
F2 minus
I have
F1.
0.
And we don't have
And then
that.
time of B.
So,
A to B at 1 second, and then time, I was at 5/10 of velocity.
Should I just be saying that because
Meters per second.
that's our starting point?
He's jealous.
Yeah.
That's as straight as I get.
okay, well, we know the time.
So like
Velocity
position meters, that's what it is.
at
Meters a second. This one, so this will have the time.
Okay, guys, let's talk about our graphs. Are y'all, yeah, let's discuss.
It's another hour.
Okay, so first, when you were constructing your graphs, what was step 1? What choices did you have to make? Melissa?
We had to figure out where our axes were gonna be.
Okay.
Backside.
Your axes?
Axes.
Okay. What else did you have to determine about your axes?
Which is your X variable, which is your Y?
Okay.
How we
What your
want
variables were
independent.
gonna be your independent and dependent variables? So what did you choose for your x-axis?
I chose time.
You chose time and what units are time in? Seconds. Okay, what on our position versus time graph? If the x-axis is your time, then the y-axis is position, okay? So on your position versus time graph, I'm gonna show you mine. And Brenda and I had a very interesting conversation about this scale. That this scale really doesn't matter as far as the slope of the line unless you're in marketing. And you're trying to illustrate profits or whatever. Then people who don't look at the scale or the units go, ooh, that's a steep line, that's good. So, in science and math, it absolutely matters. Okay, so the position here I have in meters. My time is in seconds. My meters go from 0, or I have -1 as my point of origin, all the way up to 2. My time in seconds starts at 0 at the origin, and I went up to 7. So I graphed the points over, or the points in meters at certain times. Now, Brandon had some really good insight as far as the what, okay. Do you not want to share your insight?
No, it's fine. I asked them to verify what I said.
Okay. Rochelle?
Okay, question. It looks like a proportional when he starts going down, but shouldn't it be, on mine it looks steeper because he went faster. No, it just doesn't, is this the way you did your units? It just doesn't
No,
look.
it's steeper.
It's steeper,
Okay, mine was just like,
yes.
Let me
It's
zoom
the way that
zoom
you
in on the steepness. Okay, what Brandon mentioned is that when you graph your points from your data table, that the question was, do you connect the dots? I connected mine, but upon reflection,
No.
I don't know that I would. Why? Why wouldn't I connect these dots?
As I was thinking, I don't have enough information to tell me if I'm thinking, it's not enough information telling me if he moved at like a constant or not, because in a half a
At a
second.
constant what?
Constant speed.
Okay.
That's the correct word. So in my mind, he could have been at a half or a second, he could have moved 7 meters, for example. And then, but at 1 second, he was obviously at back to a half of a meter.
Okay, so what he's saying, I think, and if tell me if I'm saying, re-saying
I don't know
this
if I'm
correct,
saying it correctly.
is that the only data we have are at those certain points. So somebody was measuring the position at certain times. The position between those 1 whole second increments was not measured. So the data we have are only at those positions at those certain times.
It's the Toby syndrome, between each second. You could change, stumble, trip, whatever, or run down a small hill between second 1 and second 2.
But you're not talking about
But it doesn't
speed.
matter, because you still go
But-
from point A to point B.
Right,
in
but
that time.
something could happen in between it, so it's
But then
really.
your position would change and then you'd have an extra point.
But your position,
But we only measure the positions at certain times.
So we only have
We didn't
discrete
measure-
points of information.
We only have discrete points. Good.
Is that right?
I don't know, it sounds great.
It could be the flash right off to the
yeah, but
side.
we know that they had been walking to be able to get there in that time.
But maybe they walked like this.
It doesn't matter how they walked or if they magically poofed
Or
their
if they
Because your graph is
Or
showing
jumped to the next
position,
point.
not speed.
Right.
graph is
That's
showing
exactly right. They're
position
showing,
and the
it's
time.
showing position,
Not
not
speed. So it doesn't matter if you jump and then you tiptoe. Like you're still moving that way, so your
Well,
we
position
know
is
you're
still
going in
showing.
that
so
Right.
if we take a point on the line between, I don't know, position D and E, whatever that answer would be on an E, does that mean it's going to
They
line
had to
up
be
with
about
that?
Now,
Just
what
sit
about
back.
this? What about this? Maybe this dog went, oh, squirrel, I'm gonna go up here and then I'm coming back here.
Within that-
fraction of
So
But he
what-
was still
what-
heading toward the
What
next
Brandon
point.
is saying is that we don't know what this dog did in this time. We only know that he was here at 3 seconds and he was here at 4 seconds.
So, or do we have a half of a position? Because that's what the line would show if they're
We
connected, that
didn't,
we
we didn't
have.
measure that data point.
Right, but if you leave them connected, that would infer that you have
You got 3.5
a
seconds.
positions
Right.
between B and C, but we do not.
Right. Now, if we had more information about this
No,
dog,
I agree with Brendan, I'm just saying,
that if we were told the dog walked at a constant rate to that.
and in a linear
And
path.
turned around and then walked at a constant rate back, then this would be a little easier to do, right?
Laura,
Ashley?
are we still talking about, that's the difficulty, or I guess, of still debating between distance over position. Because if you're talking about he did this, this, and that, now you're talking about, well, that's the distance he
No, I'm
traveled.
talking about his position.
Right, but this is just position. I took a picture at 3 seconds and then I took a picture at 4
Yes.
seconds.
Right.
Now, what he did in between, that,
So there should be no
neither here nor
line,
there.
there should be no line in between.
Right, so, yeah, if he does the hula balloon and flies
So-
to outer
so
space,
like-
comes back.
like, for example, we hunt, okay? So we have game cameras out in the pasture. If I take a picture once an hour, set my timer, the camera's gonna go off once an hour, and I see a deer here, and then an hour later, I see the deer here. That doesn't mean that deer, if I'm mapping the position at 1 hour and 2 hours, that doesn't mean he absolutely went at a constant speed through there. That just means he was plotted here and he was plotted here.
Right.
He might have gone somewhere else and then come back to here, but his change in position was captured at those times. That's what Brandon is saying here, that we can't necessarily connect those lines to infer that he was at these positions between those points, okay? Okay, now let's look at our velocity versus time graph. Let's look at our velocity versus time graph.
So we don't know if you're supposed to.
Yes.
No, I just want to clear something about the steepness of the graph.
Yeah.
That just depends on what you use for your intervals, right?
Yes.
Yeah.
Okay.
Right. Yes. So what did you use for your x-axis on your velocity versus time graph?
That one should be
What did you use for your x-axis? Time, okay, so then what did you use for your y-axis?
Velocity.
Okay, time in seconds, velocity in meters per second, okay?
No.
So,
Oh,
like this, correct?
yeah.
Okay,
Then they should be the same.
so then your scale is your own.
It should be the same.
They should be same points, so.
Then what did your velocity versus time graph illustrate?
What did your
Constant, and then
Okay, wait a minute. What did your velocity versus time graph show you about the dog's motion? Velocity versus time.
Looking at the table, I'm looking at a table, that it was constant for a period of time and changed and remained constant for a period of time.
State
It was
that again.
constant for a period of time, changed, and then was constant again for a period of time.
Okay. So the velocity was constant. What does that look like on a graph, on a velocity versus time graph?
Straight line,
A straight line in what?
horizontal, along the
line,
horizontal
okay.
line, and then down below, I don't know if you can make them or not, but you go down negative direction down and stay constant for a straight line.
So does it stay constant going in the negative direction, or does it?
no, he's
It
saying
changes velocity.
Yeah.
But wasn't
It's
a
not
constant,
constant.
but wasn't a
No.
constant decrease.
No, it was
Okay,
instantaneous.
wait a minute. What I'm asking is that you said there's a horizontal line, and then the line goes down, there's a line going down, and it stays constant. What I'm asking is, does that line going down stay constant, or does that line change to a different shaped line, or a different angle, or what remains constant is what I'm asking.
Stays a half. All right, so at 1 second, it's a half.
It's a what?
Second,
Wait, it's a half what?
It's a half meter per second. At second 2, it's still a half meter per second. At second 3, it's still a half meter per second. At second 4 is a half meter per second. But then at the next second, it's -1 meter per second. So, 0.5,
So
1.
they're saying this.
So now it's
This is the 1 second word, and this is the 2 seconds. Because see, I was looking at the table.
So,
So it,
Because I couldn't figure out the time.
oh, I'm not plotting it right.
so I'm asking about the shape of the graph for, and I know what your graph looks like, because I'm looking, I've seen your graph. I'm asking you to explain to me what your graph looks like. So you said it's a horizontal line,
Yes.
and then it goes down, and it remains constant. That's where I don't understand.
Now it's,
Those are constants.
yes, it's a constant, negative one, so it's constantly going straight down. Is what,
Like this?
I think that's what I'm wanting to say.
So, okay, let's,
Oh, you know what? Probably doesn't it? Oh, it flattens out again.
what is it?
The X value will remain the same, like -1.
Okay, so the x value, if this is -1, and over time, you're saying it's gonna remain the same?
That's
So what would that line look like?
Would be horizontal on the X-axis.
Okay, so you're saying the shape of your line, you have a velocity that's not changing, so the velocity is remaining the same, and then down here, the velocity decreased, and then the velocity is remaining the same.
That's
Okay,
what I'm
is that,
trying to say.
okay,
But how can we draw that line between where we have with a change? How can we draw a line there?
To me, it's
Or actually any line,
That's what she's getting at.
again, because if you're looking at instantaneous velocity at a certain time, again, you can't have a line. You can't draw a line.
Do we have
Looking
an
at instantaneous velocity.
Can we have an instantaneous velocity though?
Yes, because you gave it a time, a certain second, bam. Then you have another second,
Right, but remember
bam.
velocity is a change. So you can't have a change at a specific point in
so
time.
maybe that's a question we need to discuss then, is that
You were
on
saying,
on the
yes.
first one, we said that you may not want to connect those dots, but here,
We said you couldn't.
Toby is saying that we shouldn't connect those dots there
I'm thinking
either.
maybe we shouldn't, because
Okay.
From,
something,
maybe from the change.
I don't want to interrupt.
You know, like the step, between the two steps, there may not be
Okay,
the line, but
so we're saying that we couldn't infer in the first graph the positions between the times, so maybe we shouldn't infer in the second graph as well?
But I don't know how you get,
Russell, do you want to weigh in on that?
What I've been wondering is this, is that on the first one, you had, on the position versus time graph, you had the discussion about you can't really draw a line between the dots, because you don't know what happened in there. Why could you draw a line
On the
between the
side
dots on the next graph?
That's what
yeah.
we were saying that you shouldn't then, right?
Okay, so then, that would mean that what you need to do is, I guess, just draw a dot,
Dots.
which means the velocity at that time is that number? How do you calculate velocity?
That's what, well then, because the velocity is the change in position.
Over time.
Oh,
And hear the old word.
Per time.
are you?
hold on, you said an O word, that's nothing to do with ton. Oh, that was. Right.
Calculate.
So it's a change, so you have, so it can't be a discrete dot at a,
It can, but a velocity, I like to think of it as the rate of change of position.
right.
And to calculate that rate, we need a change of position and a change of time.
So to show the change in time, that's how we are
But to
able.
show the change in time, we need 2 times.
Oh, yeah, so we can't.
So at which time do you draw the dot?
And the time
So-
that's kept,
So when we calculated the velocity, we were actually calculating the average velocity between 2 points.
So your dots would
Yes.
be between 2 and 3.
Which I would infer to be the one constant velocity that would have gotten us the same change in position in the same amount of time. That line that you could draw in the first graph that would connect the dots.
So you're saying,
That
yes,
line
connect those
on
dots?
On the position versus time graph that you drew initially and then said maybe I shouldn't, that would be the one constant velocity that would get you that amount of change of position in that amount of time.
So what are you saying?
Does that make sense?
Whoa.
You're saying that pretend the deer, you don't know what the deer did, but you said, based on the two pieces of information I have, I could calculate the average velocity of the deer during that hour.
So which means we
It would have been slowly moving
connect
his
the
way over
dots
here
on the.
pretending that.
So if we treat it as continuous data, it would be an average.
And then that means for the entire time interval,
The average
the
velocity.
average velocity is that number that you calculated. And that would be a horizontal line between those two dots for that time interval.
So we can connect the dots on the velocity and time graph,
Yes.
but still not connect the dots on
You can connect the dots on the other ones, because now you're saying this is, we're assuming it's moving at a constant velocity between the dots.
Right, but it's not an average such as velocity.
See, on the velocity versus time graph, two dots at two times. Okay? And then later you see another dot. And you look at it and you go, those are lined up, they're all the same number. Doesn't mean there was a constant velocity between them, but we don't know that, so we're just gonna assume it is. And draw a horizontal line here. And if, once we assume that there's a constant velocity between these two velocities, because we're calculating the average. So one constant velocity that would be,
Well, I get the average part in being able to assume that we can connect the
Right.
dots. However, I don't, that we can just assume about the position and time graph. Because it's not, like we said, mentioned with Brandon and our Toby, we are taking an instantaneous position. So we just can't assume
So the points themselves are the points?
on both graphs.
I see what you're saying,
Okay.
I think.
Since it's an average, we can connect. But since position is not an average
Well, then maybe
position,
we don't connect on the average velocity graph either, even though we should. If we're calculating average velocities, we're calculating for the entire time interval. We're saying, what's the one constant number that was applied to
so
that?
I get that, I agree with
I
that.
understand what you're saying,
On the
but,
position versus time graph, we're gonna say what constant,
Because you're saying.
I don't wanna use the math term, what constant line can we draw between those two dots?
my question now comes to, once that constant velocity has changed to a different constant velocity, can you connect the dots?
Between the
Because you don't
two.
know how, do you really know how it changed?
I do.
Well,
Because it's an average.
At 4 seconds, isn't it?
yes.
Where it changes velocity?
We're taking an average.
So, if we calculate on the velocity versus time graph,
Yes,
an average velocity is 2 times for that time interval.
right.
4 seconds is gonna show up twice. 4 seconds will show up as the final time point for one of the measurements. And for the other one, it'll be the initial time point.
Right.
So what average velocity belongs for the 4?
Now, let's see, now let's-
Can a science teacher please put that in science terms? Do we connect the dots or not?
Yeah, but you're getting that finally.
Yes on the velocity graph, no on the position.
No, because like he's saying, if you say yes to the velocity graph, then you're making assumptions.
No,
If you make
because it's-
assumptions,
we're
then by God, we are connecting
But we're
the dots on the
taking,
first
but we're
graph.
taking an average. We're
Right.
calculating it
Right,
differently.
thank you, Russell. Bam.
Give
Russell's
her
spoken.
the weather comes best fit.
But we calculate an average differently, and we calculated the position.
But you're using the data points from the first one. So you're making assumptions from the first one to make calculations on the second.
But we had discrete data for position, and yet we
Right.
calculated something
But you're saying
completely
based on the
different for
first graph,
velocity.
you're saying if it's not discrete, like it is following a pattern between, seconds 1 and 2, between seconds 2 and 3, you're making assumptions that if this data table stays true and it doesn't change in between, then I can calculate the average velocity based on those data points. So if I can make connections and make assumptions on the first table, you can connect it out in the second one. So because you're making assumptions on the second one, You can therefore.
Using the data points from your first graph, then you can make the assumptions there.
I think it's to use the word assumption. I'm
Well,
not
that's kind of
assuming
what we're
anything, I'm
doing.
calculating mathematically.
Based
Given
on,
the
given
data
that nothing
points
else is
of the
changing
first
in between.
On the empirical data.
Exactly.
Theory should be, but it's based on this graph, you know why. You don't connect this.
I think as teachers, we think too much into the students, I don't think they say, well, what could he happen? And you know what I mean? They're just gonna assume that these are the points.
So to
They're gonna
calculate
assume this
average
is the flow.
velocity, you're assuming that nothing's changing in between those other data points on the
Right.
first graph. So you're assuming from position point A to position point B, I'm going from A to B. You're making that assumption. So if you're making that assumption, therefore I can calculate the average velocity between those points, assuming nothing's changing.
Well, even if something did change, let's not assume nothing changed. Let's assume something did change.
Well, then it would be different.
But we still get the average. So whether he sped up or sped down, we're still getting the
But depending on
average.
how much you
So
speed up
that's
or
the same
speed down,
thing as
your
going
average
from
may
one
change.
point to another. We know he went from point A to point B. No matter how he gets there, he went from point A to point B.
We're just making
Somehow he got there.
Okay, here's,
Hang on, hang on.
An elementary
just a second.
The third point of view.
Hang on, hang on.
I just like this conversation.
I have a question.
Yeah. No. Yes. Let's move on.
that's what.
The second graph, is that a velocity versus time graph?
Yes.
Yes.
Then we should not be able to draw the lines.
I say if we're doing the average velocity, if you change your
If it's an
y-axis to
average
be average
velocity
velocity,
versus time graph?
yes, then I say you could.
An average velocity.
Okay, so then what is that?
Correct. Yes.
What is it is a velocity.
I'm just saying, like, if you change your
Suppose if we
y-axis
took
on
an
the second
average
one.
position versus time graph.
There you go. You could have an infinite number.
So
of
this is not an
positions.
average velocity versus time graph. So it says velocity versus time.
Oh, so in our data table,
So-
we've calculated velocity for each
Change in
point in
time.
time. Gotta say it differently.
So I think if you change your
Time.
y-axis to be average velocity,
Well,
then you're making
yeah.
assumptions on both. If you just have a velocity versus
Yes.
time, then that's when you can't connect the dots. If you change your y-axis, I think, to be average velocity, you're finding the average between point A to point B,
I don't see
point
average
B to
anywhere
point
in
C.
these graphs though.
So regardless of whether anything happens in between those two, that 1 second, second, whatever, if you're assuming you're calculating average velocity. So if you change your y-axis on the second graph to be average velocity versus time, then I think you can connect the dots.
Well, or clearing up something. For the velocity on page 2, we are given that the velocity is delta position divided by delta t.
Is that average velocity?
No, velocity, capital V.
You mean instantaneous velocity?
Yes. And then on page 3, it has given us the average
Wait.
velocity.
Wait, capital V is,
So the velocity is the change in distance, the change in position over change in time,
That's what I, yes,
right?
okay,
But you have to have two positions,
I understand that.
2 data points.
So still change in position
So
divided
when-
by change in time.
Right,
But
so
when we get
look
to,
back, just a minute. When you are calculating when you're measuring your change in distance, your change in time, you're measuring it between 2 points.
yes, I am.
So is that instantaneous, or is that an average between these 2 points?
Well, then why wasn't this called average velocity on page 2?
That's what we were.
Because when you have 2 points.
So we have never done instantaneous velocity in this activity.
Yes, we have. It's in the data table.
That's what she's saying it's
But
not.
you're using 2 points of reference to calculate the change in distance over the change in time. So it's 2
Okay.
points. So your average velocity between A and B was
Right.
0.5 meters per second.
So we have always used, or we have been using average velocity in this entire activity.
Yes.
What I'm asking, I guess, is that point that you're looking at right now, that number.
That's
okay?
That's an
At
instantaneous.
what time should that be labeled or marked on the velocity versus time?
Yeah, that's what we've been looking at this whole time.
Because they're all ones, I don't know.
No, can I, so, velocity, no point in my saying like.
That's why we didn't graph it, because we didn't have a time.
Because they're all ones, and I'm like,
So even if it graphs like.
you know, one second, I'm like,
Okay, there's 5 conversations going on. Ashley,
Okay. I'm having a problem with everybody saying average, average, average. Well, we did the average with A and G, but what I'm saying as a 5th grade new science, so between A and B, that's a velocity. And that's calculated at B because A is 0, that's the beginning. Then.
does that matter?
Well,
This is a
actually,
reference
actually
point.
you can have velocity, I guess you could have velocity at A at 0.
I mean, I see it as like the, with the meter stick with the ends cut off of it.
Right. Right.
okay.
Because you're
So-
looking at a difference.
So then you have B and C, and that's a velocity. And that's at this point, or instantaneous, it's that velocity. And that's what we're plotting. What is the velocity here? Now here's the velocity here. Why?
Well, that's what I was asking, is this?
I'm having a problem with everybody saying average, 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 average. And whenever I think average, I'm saying, in my mind,
I
I
add 2 numbers
want to have a whole series of data averaged together to have one nice neat package of this is the average. I see the graphs as being the velocity over time as these points.
So during this
Fixed points in the
time between 0 and time 1 second, 5/10 of a meter was covered.
Right.
So over this 1 second, 5/10 of a meter was covered.
And that's the velocity at that point.
Instantaneous.
No, that
That's
is
the
the
average.
velocity over that time period.
Right, okay.
1 second is not a point, it's a period of time.
Instant time.
I'm sorry?
Not a period of time.
Oh my God, can we answer this? Which one is it?
From 0 to
Instantaneous?
1 is a time interval. Right. And we know a number for that. What is getting to me, I think, this is my math, remembering from a long time ago, is there a thing called the mean value theorem?
Yes.
Was that the one that said that somewhere along a curve, there's gonna be a slope of a line that is the same as the average, the slope of the line between 2 points? Wasn't there a way of calculating the calculus? By taking smaller and smaller time intervals, so that this discussion doesn't have to happen? Because we only know how to calculate averages. So we can.
So answer time.
Block this motion off into this. Straight lines for intervals. For the position versus time, for the velocity versus time. And then make smaller intervals if we want a more precise answer. But that's all we're doing. It's getting smaller intervals of little pieces.
So they're little averages.
They're little averages.
Okay.
Taking
See
the
that-
average as the time interval goes to 0. That's when you get to this one, that's
Okay.
a curve and a tangent. So the basic idea though is that this is a good discussion of how often do you need to sample something before you can make something, where you can say something about it.
True.
Say, I can say on average, this is what the deer did or this is what the dog did. But I can't say what it did between the measurements because I wasn't there.
And even if you make those measurements smaller and smaller, you still can't say what happened
Between the
between
measurements.
those
That's
measurements.
So, because of that,
We are going
we
to,
do not
or
connect the
we are
dots.
not going to.
That's like we're having a discussion, but we don't have an answer, just trying to meet
Yeah,
that.
you know, a referendum in the classroom where they say, do we want lines or no lines?
And do they?
Because no lines means you're looking at the dots. And yes lines means you're looking at a lot of dots.
Right.
Whether those dots have significant meaning, really only by a physicist would be determined by whether you needed it to. How precisely do you need to calculate the orbit of something? You need to know to the nanosecond where the thing is? Or can you just say it's here and then it's here
Not
and
for
it's here
this.
and it's here?
Not for this.
We're good.
Okay, so as you take your student through the concrete level,
We don't get to do that.
With concrete.
with concrete, using concrete, you know, you could take them outside and actually do it on concrete, by the blocks of concrete. Are you going to time them in between the main point that you want? You know, from point, this point is the end of one piece of concrete that is the same length as another piece. Or are you gonna have people in between those points all the way down? It's a lot of stopwatches. Okay?
What you're saying
So-
then is that no graph in existence works. What, that's what you're saying
It
basically.
depends
is
on
that-
what you're going to use it
No,
for
no, no,
and what you're
because
looking at.
any point of time can be broken down, which is what he's been saying,
Yes.
into smaller and smaller
Any interval
points.
of time.
And any interval of time can be broken down into smaller and smaller
Right.
points. And because you cannot guarantee that all the electrons, all the parts of whatever object that you are measuring were traveling in that direction, you are saying essentially that no graph can ever be created. Or not the graph, that no line can ever be connected.
So you have to set, do you set the rule with the student that this is what we're measuring at this particular point in time? You've gotta let them know. Now, for a little kid, right here, right here, right here, let's use a,
adults too.
yes. And this is what it looks like. Is it fair to let them draw in the line to have a better visual representation of point to point? For especially intermediate student, or middle school or high
Or
school.
middle
For
school
a real
teacher.
dog, that graph probably wouldn't be true,
Right.
because he would not be at 4 seconds
That's what
at a position. And a constant velocity before and a constant velocity after. At that position, he would slow down, stop.
Sniff something.
Milliseconds would go by, he would speed up in the direction, and you start getting a little round off the curves and stuff like that, trying to match the physics. If you're still trying to get the concept of average velocity,
Yeah.
then just say for the time interval.
Yeah.
Average velocity for the time interval, and then when you look at these things, you'll have an instantaneous average velocity change at 4.
You remember Tron, the TV show, where the guy would be in the Tron car and all of a sudden he goes, and he turns one, you know, a direction, and the guy that was sitting with him that wasn't a Tron person, he hits the window. You know.
Yeah, I didn't either.
That would have been a good thing.
Okay, let's, deep breath. And very quickly, there are 4 statements here. I want you to read those, think about them, process them. Decide whether they are true or false, and if they are false or ambiguous, I want you to rewrite them so that they are true and not ambiguous. Yeah, I think that's what you can look at your chart.
It's going to be true. Behind us, that would be a T. Velocity of 0.
I'm back, we're back.
You know, you can Google
question. My 16-year-old son is in physics and is having a difficult time understanding that when we drop a feather in a balloon ball in a vacuum, that they fall at the same rate.
We just did that one.
It's with the dogs.